Hi, this is Manman. Welcome back. Now today's topic is effluent treatment mechanism in seafood processing industry, especially in shrimp processing industry. So effluent treatment mechanism (ETP). So the mechanism comprises three steps: physical treatment and chemical treatment and biological treatment. Physical treatment, chemical treatment, and biological treatment. Uh, Before going details, we should know the process steps to purify the effluent water, which can be irrigated to the fields, which can be released to the nearby water bodies or streams. The first step in effluent treatment is basket chamber, and the second one is oil trap. Third one is equalization tank. Fourth step is flocculation channel, and the fifth one is primary clarifier. Sixth one is anaerobic oxidation chamber, and the seventh one is biotower. Eighth one is aerobic oxidation chamber with SAF reactor system, and the ninth one is sludge drying bed, and the 10th step is treated water tank. 11th step is multigrade filter, and the last step, final step is sludge drying bed. Before going in details about the entire process of effluent management system in seafood industry, let us now discuss about the definitions of the mechanisms. The first one is what is pollutant, what is contaminant, what is sludge, what is floccules, what is MLSS, what is COD level, what is BOD level. Let us define those points. A substance which is already present in nature, grows in quantity by human activity, which can adversely affect to the environment, is called a pollutant. Examples: carbon dioxide, carbon monoxide, sulfur dioxide, etc. Then the second definition, what is contaminant? A substance which is not present in nature but produced by the human activity, which can adversely affect the environment, is called contaminant. Best examples are most of the pesticides. Pesticides which are not present in the environment, but by the action of humans, the pesticides are produced and adding into the environment. So this is called the contaminant. And pollutant means the substance which is already present in the nature by the activity. It grows in quantity by the activity of humans, increases the levels, harmful to the evolution process. And third definition is, what is a sludge? Sludge is nothing but a mud-like residue that can contains contaminants, organic matter, and nutrients. What is floccules? Small, loosely aggregated or clumps a bit of material suspended in or precipitated from a liquid is called floccules. What is floccules? Floccules is nothing but a small, loosely aggregated material precipitated from a liquid is called floccules. During the MLSS process, the effluent system, you can observe the floccule formation as well as the sludge formation at the bottom and floccule formation at the surface of the water or surface of the liquid. And what is MLSS? MLSS means mixed liquor suspended solids. MLSS is the measure of total concentration of suspended solids present in aeration tank. During the activated sludge process, MLSS can be generated in the aeration tank. You can observe. So the total suspended solids which are present in the aeration tank. BOD is nothing but it is the measure of amount of dissolved oxygen required by aerobic microorganisms to decompose the organic matter in a given water sample for a specific period of time. So that is called biological oxygen demand. Now biological oxygen demand 20 to 22 degrees centigrade for 5 days they are testing. So what is the BOD levels? And what is MLSS? MLSS means mixed liquor suspended solids. MLSS is the measure of total concentration of suspended solids present in the aeration tank. During the activated slides process, MLSS can be generated in the aeration tank. You can observe. So the total suspended solids which are present in the aeration tank. BOD is nothing but it is the measure of amount of dissolved oxygen required by aerobic microorganisms to decompose the organic matter in a given water sample for a specific period of time. So that is called biological oxygen demand. Now biological oxygen demand 20 to 22 degrees centigrade for 5 days they are testing. So what is the BOD levels? Then what is COD? COD is a measure of amount of oxygen needed to oxidize the organic matter in a wastewater. What is organic matter? Organic matter is nothing but which contains carbohydrates, proteins and fats. As I said, the ETP system, effluent mechanism in seafood processing industry. So mainly physical treatment process, chemical treatment process and biological treatment process. But biological treatment process we have to ensure that biological degradation of organic waste done in an effective manner. Why? Because mostly we people are using chlorine as a disinfectant. Potable water we are using 2 ppm chlorine, but whereas floor washing, utensils washing or something, sometimes when there is an inspection you have to wash floor with higher concentration of chlorine, 200 ppm or 100 ppm, or sometimes non-food contact areas you have to scrub with bleaching powder. Through this video, my request to the QCA and QA community to enhance or to optimize the biological degradation process in effluent treatment mechanism in seafood industries. We must convince our senior management to construct separate collection tank or separate equalization tank. Why? Because if our effluent treatment capacity or if your production capacity is 30 tons per day, for example, means as per the regulatory requirements or other standards, for 1 kg of finished product we have to use 10 liters of water. 30 megatons means 3 lakh liters of water can be consumed. So your collection tank should be 2 numbers, each one can hold 3 lakh liters of water. Then what happened? The entire day, the collection tank can, then what happened? It will take 1 day to top up the collection tank. So then second collection tank, you can divert the water to the second collection tank, spare tank. And over the period of time, maybe, why? Because we have to neutralize the chlorine residues. In seafood processing industry, during washings, cleanings, generally the potable water is 2 ppm. That won't deter the proliferation of the microbial flora, or that won't kill the mechanism of biological process. But if you wash the floors or if you wash the utensils and drainage systems, 200 ppm, 100 ppm, like that you're doing. And Chinese requirements also more higher than that. Or sometimes you may scrub the floor with the bleaching powder also. Some facilities maybe. So what happened? The chlorine levels, the chlorine concentration reaches to the collection tank. If you cannot neutralize the chlorine concentration, which are collected at collection tanks or equalization tanks, chlorine neutralization will take place 12 hours minimum, 12 hours to 1 day. Once you collect the effluent in a collection tank, then let it be in 12 to 24 hours in that collection tank and run the aerators. So automatically the chlorine concentration which are present in the effluent water will disintegrate further and disintegrates into the chloramines, hypochlorous acid, and finally further deteriorates, neutralizes. Then you can pass the water to the further process. Some seafood industries only having one collection tank. How they will ensure the chlorine concentration, the chlorine residues in the effluent water completely neutral. If any residual amount of chlorine is there in the effluent water, then what happened? It goes to the biotower. It's a biological process. Effluent, we can ensure the pure, we can ensure the treatment process by physical, chemical and biological process. Here, biological process completely retards. Optimization won't occur if chlorine levels are present in the effluent water, 2 ppm or 3 ppm or 4 ppm or like that, something, 1 ppm or something, might be there. We have to neutralize. Once you collect the effluent water, let it be for 12 to 24 hours and run the aeration tank continuously. Automatically, by the sunlight and aeration, air diffusers, submersible air diffusers will neutralizes the chlorine concentration. The chlorine also further disintegrates and finally neutralizes. Then you can pass the further process. If you are not neutralizing the chlorine residues, then the water you are passing through other steps like biotower. What is biotower? Biological degradation will occur. Biotower you have to maintain. Now the PVC emitted biofilms are there. Every industry is spending lakhs of rupees to procure the PVC emitted biofilms. Means microbial flora, aerobic mesophiles, PVC emitted. It will take, it's very expensive, lakhs of rupees they are investing, and the PVC biofilms are there, PVC emitted biofilms are there, and once the water is sprinkling on the top of the biotower, water can sprinkle maybe to 15 or 12 sprinklers, they will arrange and the water sprinkles, and air also will dissolve, and whatever the organic waste which are present in the water can be biologically degraded by the microorganisms which are present in the same, without neutralizing the same water. If you can pass to the anaerobic tank and you can pass through the aeration tank, what happened? Daily we are adding urea and DAP for proliferation of microbial flora. So for propagation, the microorganisms requires phosphorus and nitrogen. And in addition to that, we have to top up the raw cow dung also, natural flora. We are introducing the natural flora also. What happened, once without neutralizing the chlorine solution, okay, then you pass the process steps, then it will oxidate the entire microbial flora, entire biological degradable, entire microbial flora, which it will oxidate the entire microbial flora which are present in the aeration tank, which are present in the anaerobic tank, which are present in the biotower. Effluent treatments in shrimp processing industry must equip MBR technology. So in addition to the conventional methods, they should equip the membrane filtration technology. It's a tough task to remove the higher loads of TDS and TSS. Especially in shrimp processing industry, if you produce in a day, if you are producing 30 tons of finished product in shrimp processing industry, most of the shrimps are treated with phosphates or non-phosphates and salts. To produce 30 tons of finished product, if you add 2% of salt, means per day you are adding 600 kgs of salt. So 600 kg salt in a 3 lakh liters of water. That means 1200 ppm of chloride content in the effluent water. You got my point? Convince the management. For soaked water, there should be a separate sewer lines for soaking mechanism where it takes place. If we optimize the effluent treatment process, and if we ensure our sustainability mechanism is functioning well, then we must divert the treated water in a separate bed, like sludge drying beds. Like sludge drying beds, we have to divert. We should construct a separate drainage system for treated waters. I mean, per phosphate or salts or non-phosphate treated area, soaking area. Connect the drain, separate drain. Every industry should equip the separate drains for soaked water. Why? Because soaked water contains higher amounts of TSS and TDS, especially the chloride contents. If you produce 30 tons of finished product, treated product, shrimps, then 600 kg of chloride, 600 kg of salt you have to add. 600 kg salt means in that 600 kg comprises salt is nothing but salt is a molecule, sodium 40%, chloride 60%. Then the salt 600 kg salts contains 240 kg of sodium and 360 kg of chloride. So 360 kg of chloride dissolves in 3 lakh liters of water. Why 3 lakh liters? To produce 10 tons, we may require 1 lakh liters. To produce 30 tons, 3 lakh liters of water. So 3 lakh liters of water utilized and the 30 tons material produced. Then the chloride concentration also added 360 kg. If we add 360, if the water contains 360 kg of chloride in 3 lakh liters of water, which gives rise 1200 ppm of chloride content in the water. Plants can absorb, as per the WHO guidelines, the chloride limit is 250 ppm in a potable water. But for irrigation, 500 ppm is okay. Plants can absorb the water. But what about above 500 ppm? Means if we add 2% salt, the water chloride contents reaches to 1200 ppm, which is toxic to the larger plants also. Even banyan tree also, due to the toxic levels of chloride, can be destroyed. The plants, due to the toxic content, toxic chloride content in the water, the root absorption mechanism completely collapse. The plant cannot absorb the water due to the higher levels of chlorides, due to the higher levels of TDS, due to the higher levels of TSS. So before discharging into the nearby agri fields or before discharging into the natural lakes or streams, so we must treat the water with filters, membrane filtration technique, which can filter the chloride ions. It's like RO mechanism, reverse osmosis. Okay, to maintain certain pressure, so the pure water comes out from the membrane filter, MBR technology. So we should equip the MBR technology after the aeration tank. After the aeration tank, we should equip the MBR technology. Or if it is expensive, okay, simply divert the phosphate or salts treated water into the separate sludge drying bed. Because some areas soil mineral leaches will occur, you can top up that areas. Soil also some areas chloride content will be very less because leaching will occur. Maybe inundated areas are there, or flood areas, frequent flood exposed areas are there. Maybe leaches of mineral content might be there. You can top up that areas. It won't harm. But if the water contains chloride contents, dear friends, about 1200 ppm, then which can kill the bigger plants like banyan tree also. To reduce the chloride content, the only solution is we should equip membrane filtration technology, MBR. It's nothing but RO, synthetic biomembranes, synthetic membranes, after aeration tank. So we can ensure that. In such a way, we can ensure that our effluent treated water, which complies all norms, and we can create sustainability environment near the vicinities. So what happened? The chloride content is more in effluent treated water. Plants will exhibit reduced growth and decreases the yielding also. Soil salination, plants absorbs the water through roots, so it will be toxic to the root system also. To control the chloride content in effluent treated water, the only option is we have to equip membrane filtration technology at the end of aeration tank, or otherwise we have to divert the treated product streams. We have to divert the water, soaked water, like phosphate or salt treated or non-phosphate treated water. We have to divert into the sludge drying bed. So after drying in the sludge drying bed area, so top up that, and you can top up where leaching of chlorides occurs at inundated areas or flood exposed areas. You can top up. Yes, that is how we can maintain the sustainability near the vicinities. Thank you. Thank you, universe, for giving me the opportunity to share the knowledge. Or after secondary clarifier, you have to equip multi-grade filter like sand and carbon filter. So after end treatment, the water can pass through the sand and carbon filter, which removes higher load of TDS or TSS. So that is also one method. So to minimize the chloride content in treated water, there are 3 steps. To minimize the chloride content in effluent treated water in seafood industry, there are 3 steps. The first one is equip the MBR membrane filtration equipments at the end of the aeration tank, or equip the multi-grade filter at the end of the second clarifier. After second clarifier, the water should go through the multi-grade filter. Multi-grade filter is nothing but sand filter and carbon filter, which can reduce the TDS, total dissolved solids, and total suspended solids. And the third one is very simple, without investments. Only you have to divert the phosphated or salt treated water into separate sand drying beds. You have to make sure separate sewer lines and let it be dry on that area. So that soil you can top up where the leaching of the soil occurs. Leaching of minerals occurs in some areas, maybe rain flood areas, rain affected areas, or inundated areas, frequent inundated areas. You can top up the soil in that areas. In such a way, we can maintain the sustainability. In our part 2 video, we will discuss about the steps involved in treating the effluent water. Thank you, universe, for giving the opportunity.